need to do here is to write it in the standard form. Let's write this in the standard form. So to write this in the standard form, we have y prime plus 4y should be equal to 2. Then today you could see that the coefficient of y is a positive 4. So our integrating factor becomes e to the power the integral of this 4 dt. And when I integrate, I'll get e to the power 4x. So this is my integrating factor. This is my integrating factor. You said 40. Okay, so that's the integrating factor. Now the next thing is to multiply through by the integrating factor. So by doing so, we will get e 40 multiplied by y prime plus e to the power, or let me write it this way, 4 e to the power 40 multiplied by y, then should be equal to 2 multiplied by, where am I? Okay, 2 multiplied by e to the power 40. And by now we should be familiar with this expression. So it is going to be the integrating factor, which is e40 multiplied by the dependent variable y. Then we take the total derivative of it. This should be equal to 2e to the power 40. Are we okay with this one?
Yes.
Okay.
Sure.
Now, so you see the first question was to find the integrating factor. The next thing, we are supposed to write the whole thing in total derivative. So that is what you are going to do. Remember that to write everything in total derivative, the total derivative, when you find its derivative, must always be equal to 0. So that's what you are going to do. So it means we have to first integrate here and integrate here. When we integrate both sides, we will get e to the power 40 y should be equal to, when you integrate this, you get 2 divided by 4, which is half. So half g to the power 40 plus your constant. So now I can bring this one here, which is going to be g to the power 40 y minus half g to the power 40. This is equal to the constant c, but if I should take a total derivative of it, then it will be equal to 0. So this is my total derivative. Then it means that what is inside the bracket is called a potential function, which is in the form this way. The potential function is a function of t and t of y. That's a dependent variable, which is equal to, remember, if the total derivative is given as 0, then it means that when we integrate the total derivative, the 0 becomes a constant. So our potential function is equal to c, which implies that e40 y minus 1 over 2 e to the power 40 is equal to the constant, the potential function is a constant, then from here we can solve. So here what we need to do is to divide through by e to the power 4t. Divide here to the power e to the power 4t. Divide here e to the power 4t. So we have y minus half of this one will even cancel out, is that right? So we just have half should be equal to c to the power e negative 4t. And finally, y is a function of t, which is giving us c e to the power negative 4t plus 1 on 2. So this one is a step-by-step solution. Was it an initial value problem? Okay, this one is not initial value. They didn't give us any initial value, so that's the final answer. That's the final answer. How about let me see. This C is supposed to be C. Yes.
The last, the E. Is it E?
No, it's supposed to be C. C.
Yes.
C. So C e to the power negative 4t plus half. That's the final answer. That's the final. This one is very simple. The first question, I have to look at it, then I will solve it maybe.
Hi.
Yeah, hello.